All right, so let's go over this one more time, and this time I'm recording. Maybe. Before we move on to another example and we can start to do this in real time together. Okay. I'm not really starting with any ingredients. I'm just opening up the graph. Ingredients, typically the functions and a list of numbers for a minimum, maximum for at least a U and a V domain. Sometimes there's some constants involved. Other times there's extra expressions involved in order to solve for a particular variable that then gets plugged back into the main function for either X or Y or both. So let me show you what that means here. Richmond surface. All right, so here we go. There are my things. I would probably just copy and paste this into, like, let's say Notepad, right? Make sure it's cleaned up. Make sure there's nothing from the formatting of the browser in there, and then I can try to copy and paste it into here. I might have to clean some things up, right? I just assumed that it's not going, if I put 3 and X together, it's not going to do anything. It's going to give me an error. So I use the asterisk in this case. Sometimes, like maybe if you use Wolfram alpha, I'm not sure, but that might use the implicit multiplication, just putting a variable and a constant together. But in this case, that's not the case, I don't think. So I've been very careful about making sure that I just follow some very simple rules to the most logical conclusion, but sometimes, it kind of a pain in the ass, but it is what it is. All right, so here I have the minimum maximum. Again, you can see where I get that. You can always translate, at least my browser does, from German to English. The problem is sometimes it tries to translate something in the formula and screws it up. So if you're having a hard time understanding to represent the area, 2 parameters, U and V can, for example, assume the following values in the definition range, U is an element from the set of numbers from the end of 1 to 1, right? But then you probably want to go back to German, Sie Deutsch, and make sure, confirm, right? Every once in a while there's a typo in one of these, right? So what happens when it doesn't look quite right? Or you're getting, like it's just not working. You can always, for instance, for a Richmond surface, not to be confused with Richmond, Virginia, or Richmond Hill, or commercial surfaces. All right, so Richmond surface, I could type in parametric expression, right? And you'll see that on Wikipedia, there's actually a pretty useful page on Richmond surfaces, right? Here's one way to write the expression. Here's another way. It's very similar to the way we had it, where you're solving for X, Y, and Z in a parametric fashion. Sometimes you'll find some sort of learning thing here. You'll probably find more than you ever care to know. Every once in a while, I was thinking maybe Wolfram alpha would come up, but probably help if I spelled Richmond correctly. Yeah, so Math World, right, will oftentimes also have something similar. Although I don't see Richmond surface here. Da-dum. There's Bohr's minimal surface. All right, maybe this is one of those freak surfaces that aren't actually described in Wolfram's math world. But what you'll find is that you can oftentimes find an error by finding corroborating or not corroborating evidence from somewhere else, right, and sort of compare. When it comes to these, every once in a while, oftentimes what happens is you just made a mistake. As always with computers, half the time it's user error. That happens to everybody, right? So there's a list here, and I've gone through all of these. Don't ask me how long it took. And I picked several that I think each of you can do. So let me just talk you through this here. Again, I can take the resulting surface and bake it. Right? Excuse me. I'm just going to turn this to shaded. I'll get rid of this grid. My contempt for the grid really shows today. All right. Now this is a NURB surface, right? You can see that the curves are actually isoforms. Interestingly, they're these sort of not quite concentric sort of, it's kind of a weird pattern, but it's much more of a conformal radial grid pattern. And so, you know, what's interesting here is what is an edge and what isn't, right? It doesn't see this as being an edge in the surface. So what I'm going to do is I'm going to convert this to a sub-D, right? This is what we're all going to do. You generate a surface, you're going to convert it to a sub-D and clean it up. Okay. All right, so I go to my sub-D tab. It's this one right here. It has like a cube, and it points to a sphere, and it's saying like, oh, I can take something like this and convert it to something like that. I have my cursor over it. It says, what does it say? Convert to sub-D. Yeah, that makes sense. All right, so I'm just going to select that and hit enter. And again, the options come up in the command line. Use mesh for control points. I'm going to hit yes. Mesh creases, yes. If there's a crease, I want to keep it. Yes. Control points, yes. And I'll just delete the input. I don't really care. There we go. All right. Now it's a sub-D. Now, what does that mean? It means, if I look at my sub-D tools, there's a number of them over here, right? But for now, there's these things called selection filters. And so instead of just selecting the whole entire sub-D, I can turn this on, and I can tell it I actually want to just do the faces, or I just want to do edges, etc., right? So I'm just going to do faces. I'm just going to zoom in here in the middle and grab this whole face that closes in on itself and delete it, right? So now I've opened up the edge. And I can still, remember I have surfaces faces toggled here. I can go around and delete this sort of concentric ring of excess stuff that I don't need. I can do it again here if I want. Why not? Ta-da! All right. Let me just zoom in a little closer. There we are. That's pretty. All right. Now again, sometimes these things are they look a little too simple, like there's not enough subdivisions inside. Sometimes it looks like there's too many, right? So let's say that there's not enough and I want to densify this thing. I can select it. Now, why is it only selecting the face? Because I still have this selection filter on. If I close that, right, go back over here and I can just select the entire sub-D again. All right, go to the sub-D tools, there it is. And right here, right, you see this little sub-D and it has all the little, divisions inside. I can say subdivide it further, right, boom. I can subdivide everything further. Oftentimes, you'll get something that looks really goofy because the NURB surface that was created looks really goofy. Right? We might come up against that in a couple of places. In this case, here's one of the most useful things I've ever found. Right? This is why sub-Ds are so nice. There is a remesh to quad. Where is it? Right here, quad remesh. So I can pop this in. Detect hard edges, convert to sub-D. I'll go ahead and say convert to sub-D. I'll turn preview on and see what it looks like here before I... Right, and it's going to rebuild this depending on the parameters. Right. Now, this one, I don't know... Oh, maybe... Has it done it yet? No, it's still thinking about it, isn't it? Huh. I guess this avoids having to do a... Right? Okay, so that's the new one. Where is it? And it's been converted into a nice sort of even set of quads. Right? And I can convert this back into NURBS, and then it's a much cleaner surface. Like or a much cleaner mesh than what it is as a mesh for 3D printing. All right. So that's the gist of this. Now, I want to show you some more examples, right? And then once I'm done with those examples, we'll go through the list and we'll start to delegate different surfaces to different people. And then in class, you guys can start this. I can try to troubleshoot any places where you're having any major difficulties here. All right, there's a Richmond surface. All right, grasshopper, close, open, no. Let's just go to recent. I don't feel like digging through my directory here. Let's see, oh, come on now. Going back in time. Oh Christ. All right, I will go back into my directory. Dang it. Let's see here. Oy, all right, let's see. Maybe it's in here? You know, you would think I'd learn over time to just like organize things a little better. Sadly not the case. Maybe it's in here. I don't know where it would be here. Ah, okay. Probably right there. Show an enclosing folder. Surface geometries. And this is where? Lattice research, surface geometries. Oh, okay. That makes sense. My bad. All right, so here, file open. I know exactly where it's at. Haha, which one? Is it GH or GHX? Probably GH, huh? Oh Christ, is another Richmond surface? Come on, I don't want that. Am I just dumb? Oh yeah, I guess I am. So, answered my own question, ironically. Okay, so, right. Here's a series of different types, right? This one, if you've ever been to Renzo Piano's California Science Center or whatever, right? That big green undulating roof, right? Basically just a set of cosines and sine waves, right? And so, if I can zoom in at all here, come on, right? Oh, seriously? Essentially, if you look at this in the top view, it's just a grid. So X and Y is just, well, X and Y as it steps up. But Z, what we do is we take the cosine of X and the sum of cosine of X and the sine of Y, right, to solve for Z for each one. And then here's the domain, 0 to 4 pi and 0 to 4 pi. Again, when it comes to a constant and a number, I'm going to use that multiplication, that asterisk. It's not going to recognize 4 pi without that asterisk, unfortunately. Okay. And so the result, here you thought Renzo was really smart, but we could generate this in like 2 seconds. Right? And of course, we could change the range here, right? So what would happen if we change this to 8 times pi? Anybody want to guess? It's going to get probably twice as long in the x direction. And don't forget that there's a sum involved here. So let's see. It might get taller, I'm not sure. Let's see. Nope. Just gets wider. Okay, that makes sense. Well, I guess because the cosine and sine is always, it's never going to get taller unless you multiply the result of the cosine and sine, right? It's always just going to approach 1 or -1. All right. It's like Monday over again. I don't know. All right, so the wave. Man, are there any Raiders fans in here? I'm not, but that was a pretty good game the other night. Crazy ending. I turned it off thinking they had won. And I got on Twitter after putting the kids to bed, and I'm like, what the hell happened? I was watching on Hulu, and they had the Mannings and Russell Wilson on, which I thought was actually pretty ingenious, but all right. I'm recording this, aren't I? Oh, all right. Turn this on. Solution, enable selected. All right, let's take a look at the hyperbolic paraboloid. Yeah, it's like a saddle, right? A really extreme one. Jeez. Right, so let's see. I'm really getting sick of the fact that this thing is not... Windows does not work with the drivers for this touchpad the way a Mac does. It's so annoying. Everything just works in the Mac until you run Windows on it. Okay, so U and V. Again, this Pringle is really just another grid in U and V, in X and Y. It's right here, right, where we say take V squared divided by B squared, take U squared divided by A squared, and then subtract one from the other. And by the way, here's the domain for U, in this case negative 10 to 10, so that's why it sort of spans, I think, the X, Y axis. What is going on here? There we go, yeah, so negative 10 to 10, negative 10 to 10. But then there's also something we have to sorry, this should be easier, but for some reason I can't zoom in and out. There's an A and a B variable here, right? And so we're also solving for an A and a B, which I've used as sliders, so we can always change that. And I suspect that makes things more or less extreme in both directions. Yeah, let's see what that looks like in perspective view. Right? So in this case, it's just a multiplier. Let me turn off the sound of my phone too, 1 minute. Okay. Yeah, here we go. So it almost straightens out as you get higher, then you get in towards, you approach 0, it gets better, and then you go into negatives, and again it starts to straighten out again. So it must be that extra low number. Yeah, look at that. Wow. Okay. Amazing. Never get any better than that. All right. I mean, there's other ways to make a hyperbolic paraboloid, right? In fact, here's another way. Yeah. So some of you with wood sticks probably did this in second year, actually. The nightmares return. You thought we put it behind you. U and V, again, this is a grid. That's very similar. U squared over A squared, V squared over B squared. Subtract the two together. Right? This time we're adding instead of subtracting. Interesting. So we went from a Pringle to a more, it looks like, this will probably look like a square or some sort of four-sided polygon from up above, right? Yeah. I'm starting to hear the joiner, or is that the planer? This is, what is this, a mesh? I'll bake the surface in. Bake. Right? So again, you know, I'd probably break this up into a sub D. I'm just going to do this for a few and make sure that there aren't there's not anything I'm just forgetting to tell you that might be helpful to know ahead of time here. Control points, yes, yes. Control points, yes, yes. All right. Enter. I'm just going to remap quad remesh. Yep, yep. Just hit OK this time. Wow, that's pretty wild. So there's a quad remesh. So occasionally you'll run into something like this where you go, that doesn't look better, that looks worse, right? In which case you can stick with this, right? When you do that quad remesh. All right. Let me find a better surface here. I know there's a couple of them. I think I have an innifer and a Catalan in here somewhere. If you've been to Barcelona, then you'll know about Catalan. Disable selected. Here we go. This one's different. Let's try this one. Why not? Those are all really simple and boring, right? Oh yeah, no, that's a surface if I've ever seen one. Right? There's inside out. Oh sure. All right, so a couple of things here, right? We could increase the density, of this numbers. But I'm just going to take out the surface and let's bake it. Yep. So this is like a circular disc that's been like, this is like, you know those things you put up in your windshield to block the sun? And then you twist it like this and, right? This is like if that happened, but they were able to like intersect each other, like they were just like a jelly, right? And in fact, this is what mathematicians study in topology, not topography, topology, right? This idea of how surfaces can be bent into different spaces, how many times you could tie a knot around everything, right? It's really sort of bizarre stuff. But this idea that this shape is just a simpler shape undergoing a set of geometrical transformations, right? And oftentimes that's how they start to identify certain subclasses of surfaces. All right, so if I just go to the sub D tools and I convert this over to sub D, why not? Sure, that looks good. There's the sub D. Oh, come on now. Suddenly I've forgotten how to like drive here. All right, there we go. That looks pretty good. I don't know if I'd actually change any of that, to be honest. There's a little bit of a crease there, but I suspect that has to do with the fact that this came from a surface. All right, so let's take a look at this one in particular, right? There are places where it self-intersects. Right? Now, I'm thinking ahead. Not only do I want you to be able to generate these in Rhino, but I want you to be able to catalog them. Is this making? Didn't I turn off my sound? Turn off your sound. You? Oh. All right, and so the way we're going to do that, I'll show you some examples, and then we'll go through this process here. As always, I go back to somewhere here in my geometry catalog. All right. Okay. So these were last year's. I collected them all, and then they didn't do anything. They didn't do anything regarding formatting that was the same for anybody else. So I just sit there and do these over and over again forever. It took forever. But you guys will do much better because you're awesome. All right, so these are just simple renderings in Axon with a Make2D. Right? This is just a very simple rule for the scene silhouette. very simple rule for the isoparms and for the edges of the sub-D. There's even an attempt to try to sort of even out the density of the sub-Ds for each one so that they all look like they're sort of similar. Right, these will start to make more sense to some of you. Bohr's minimal surface, I'm sure someone will get that. Let's see. Yeah, a couple of these I cut out. Inniper. This one's pretty sweet. Here's a. That's not a triangulate. That's not a trianguloid tray file. That's a Schwartz class D surface. Not a trefoil. Yeah. Okay. So, but this is essentially part of what we're going to generate as a class. Right? As you can see, this catalog. Now, for you guys, I'm going to create more rules. For some reason, every time I said something over Zoom, it went in one ear and out the other. You guys have been so good at the sort of rigor and diligence of making all this stuff look good and work so far. So, here's what we're going to do. Let's say I have this, right? This is set to perspective. I'm going to go to isometric. I'm going to try to find the best isometric. Maybe it's not northeast. Let's see. Let's try northwest. I don't know why. I like northwest better. I don't know. You know, southeast and southwest probably look the same, but just upside down. Anyway, all right. So there's a couple of things here, right? One is that if we do a make 2D where these things self-intersect, we won't actually see a curve ground as an edge unless we actually run the intersects command. Now, here's the interesting thing about that. If we take the intersect, it wants an object to intersect with another object. And so therefore, but there is a self-intersect command. Intersect self. Select curves to self-intersect. Oh wait, no, that's not the right one. What was it that I was using? Intersect, mesh, self-intersect. Oh yeah, mesh self-intersect, sorry, there we go. So what this will do is it'll allow us to select the sub-D. And it'll generate the curves for us where this thing self-intersects. So we start to see those edges. And if we run those along with the surface when we're doing the make 2D, then it'll start to include things that are hidden versus things that are visible. I also want to say, let me try to do a make 2D on this before I do a extract wireframe. I want to say that I had to extract wireframe as well. I'm going to turn off hidden lines because that's just obscenely dumb at this point. Okay, hit OK. Like, how would I make this surface more non-understandable? Turning on the hidden lines would probably be good. Nope, there they are, right? So I didn't actually have to do a wireframe for this. Okay. So there's the make 2D in Axon, right? I'm also going to go in top view and also in the front or side view. That's the most interesting or most indicative of how this surface works. And again, I'm going to do a make 2D using the same settings for top view, which for some reason is larger. That's annoying. And this one, make 2D. The key thing, I think, is to make these all the same size. I'm not sure why. Yeah, exactly. But if I zoom in and out, then the viewport rectangle will all be different sizes as well. I mean, of course, you want them to be the same size as the rendering. Well, actually, they all come in at the same size, aren't they? It's just the viewport that changes. Okay, that's good to know. Looks like it anyway. Right, so me just turn this off, the make 2D layers off. You guys sound like you're like, oh my God, when will he ever end? Are you guys okay? You hanging in there? We need to do jumping jacks, we can. I'm totally fine with that. See, I've already moved my, I'm so dumb, right? So, but if I would have to redo this make 2D, right, with this viewport size and then do that. If I do that, what I'm going to do for the rendering is I'm just going to turn this to rendered mode. I'm just going to leave it like that with the white clay, white plaster generic default shader. All I want is to make the line drawing just pop over three-dimensionally, right? So I'm actually going to turn that off. So one other thing I'm going to do, and this is because you usually have to spend a lot of screen real estate at that bottom so you don't cut off that shadow, right? So I'm just going to get rid of that shadow. I'm going to turn off the ground plane, right? So these things are really floating. I'm going to go to Edit, View, Capture, to File. If my viewport's too large, I can always change the scale up to 2 or 3, but I'm just going to use it as 1 right now. Transparent background set to yes, hit OK. Let's see here. I'll just put this on the desktop because I'm a glutton for punishment. And I'll turn this back to shaded. I'll do the make 2D here as well, along with the curves. Here we are. Right. Wait for that to happen. Great. Now, here's the thing, right? This is where it gets so stupidly dumb. That's cell last. There we go. I'll just move this out of the way and export this out as an Illustrator file. What you see in Illustrator is that sometimes these curved geometries has a hard time determining what the scene silhouette really is. So it's kind of crunked up, right? So this is where I got into real, like when I had to do like 40 of these by myself, I was like, oh my God, I would feel like just closing my laptop and throwing it across the room, frisbee and watching it explode in pieces. But I didn't. But you guys just only have to do it once or twice or, you know, however many surfaces you have, 2 or 3 times max. And if we all follow the same set of rules, keep the same parameters here, right? Keep layer management set, then we're golden, all right? I learned that one the hard way. Good grief. You'd think I would, at some certain point, be able to think more than 2 steps ahead. But all right, export selected in top view, Illustrator. So let's just go through this and see what happens here. Again, I just want to go through this workflow really quickly to make sure I'm not forgetting something critical. Oh, it'd help if I named the file. Yeah. Test srf. Whatever, I don't care. All right, there we are. There's the text srf. All right. That looks like a really large artboard. Let me just look at this real quick. 96 by 96. Yeah, it's kind of large. Maybe. 8.5 by 11. There we are. So much better. 1. No, probably 11. There we are. All right. From here, let's see. I might beef up that height to something just nice and easy. I might move this over to, let's say, 1 and 2, 4. 1 and 4. All right. So I'm just going to go ahead and place this image once I take a quick look-see here. Create a new layer. Drag that down. Lock all of these. And or make this the active layer. Place. Wait forever. There we go. Drag and drop this. Viewport rectangle was what? What was the height? 3. All right. Sorry. Somehow I forgot. Didn't take long, did it? 3. And 1. And 4. All right. Now let's take a look at this a little more closely. Turn that off. I'll lock this. Tangents invisible curves. They're already set to black. I'm going to set them to perfect. There we are. Let's crank those downwards. The scene silhouette doesn't look so bad, does it? Actually. Yay! All right, so I am so smart. Something. All right, turn that down to 1. There we are. Maybe those isoparms are a little large. Let's see. Again. Maybe I like them at 0.5. That's a little too, not enough there. All right, 0.25, why not? Sorry, 0.5, that's what I said, right? I always try 0.35, but that's just parsing hairs at this point, isn't it? All right, so there it is, right? We would do the same thing for top and a bottom or a right. So I'm not going to do that here in front of you because I think we get the gist, right? But this idea that in this catalog, I'm not sure what size these are going to be yet, but that we can have sort of, think of it as a 4-square thing, right? 2 squares, top to front or side, right, corresponding. So always rotates the front, I guess, so that the front is the one you take. So the top and the front look like they hinge and project from one to the other, right? Then the axon. And then the 4th quadrant, the 4th cell in the grid, this sort of 2 by 2, 4 cell exercise is the place for the caption along the bottom. And then what I'd like for you to do is to give me the parametric description of this. So what I want is, where's Rhino go? Here we go. What I want is this, that x equals, right? Then cosine of a, so you can copy and paste this in. So that way people could replicate it if they wanted to. So maybe I should just do this in front of you and let's just look at it and see what it looks like, right? All right, yeah. I'm always doing things the hard way. This chair does not adjust up or down. That's really disappointing. I kind of suspected it would, well, whatever. Who needs a chair up here anyway? Come on. Bush League. All right, so let's see. You know what? I'm just going to take all this Make 2D stuff and I'm going to delete it really quickly. Select objects. Delete. Really? Oh, select sublayer objects. Delete. Yeah, there we go. All right. Okay, great. And so, yeah, I'm pretty sure I like the top and the side, or top and the front. Yeah. So, let's do a Make 2D. Select the objects to draw. I'll leave these settings. I turned on tangent, I turned off hidden. We don't need hidden lines. Right? I think by default for the sub-Ds, it's already doing some of that for us. I'm just going to move this over without changing the size of anything. I'm just going to do the same thing here, Make 2D. Did it do it? That's weird. Oh, it sure did. All right. Cool. Oh, I see. Oh, select last. I'll just move this out of the way here. So make it easier later on to make sure none of these are in my top viewport or my side viewport. Right, okay. Get rid of that. Don't want to show up as a series of flat lines. There we go. Okay, so now let's see. I'm going to turn this to rendered, turn this to rendered. Yep. And I'll just capture these as well. Might beef up the size of these. There we go. PNG. Where did I save these? I just saved these to desktop. Oh, come on, Josh. All right, view. I'll also capture this one to file. Transparent background, scale of 2, sure. Right, all right, save. Yeah. Okay, so there's this one. Oh, and I didn't export. All right. So many things. Oh, this is set to render. That's why. I was like, where did everything go? Yeah. All right. Really? Touchpad. Again. All right. Export selected. Yeah, select the object. That would help, Josh. All right, there we go. Test Geo2. All right. What is that doing? Yeah, weird. Okay. There's a weird noise. Copy. When I copy and paste, I want to keep things on the same layers that they're on already. If you're not careful, when you copy and then paste, they'll put them all on the exact same layer and flatten them all out in whatever the active layer is. In order to get rid of that, if you go to the layers box and you go here, you can say paste remembers layers. Down there. So I just went to the far top right box here and to pull out the options for the layers. Paste remembers layers. I already have that set. Everything looks jaked here, so let's just pop this in. You're attempting, yeah, locked or hidden. Do you want to unlock and show all appropriate layers? Yes. Again. There we go. Let me just move this out of the way so it's not in our space so much here. I'll just move this, come on. Just move this up out of the way. Move these down here. All right, so let's see a couple of things here. One is I'm going to, again, try to make sure that these are set to the right thing. So I'll look at the stroke, change the color, just try to be systematic about it to black. CMYK black. Let's see. I think I used 0.5. I think for the scene silhouette I used 1. And I wanted to make sure those are, yep, those are good. 1. There we are. Yay. All right, we're almost done. Let's see here. Lock, 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 lock. Here we go. Place, place. Place both of these at once. Bam, bam. All right. Now, viewport rectangle. What in the heck is this size? Oh, yes, of course. 1.88. Blah, blah, blah. Okay. Copy. And select this and paste. All right. We'll move that into place. Let's see. What's this? Something even completely different. All right. Select this. Paste. Move that in. Of course. Let's see. I would make these nice round numbers so I could just not have to copy and paste them in all the time, but at this point it's diminishing returns no matter which direction I go here. So I'll just paste this in. Same thing here. Just look at the x and the y for this viewport rectangle. All right, and work smarter, not harder, Josh. There we go. Okay. And then at this point, I mean, one thing I'm going to do really quickly is I'm just going to see and make sure that these things are actually matching up. They sure look like they are, don't they? Oh, yeah. Okay, great. All right. Man, they lined up really nice, actually. Okay, great. So I'm going to move these down. I'm going to move this one over here. Wait, what? Oh, I had things locked. Of course I did. 2 steps forward, 3 steps backwards. All right. What was this, a Hennifer surface or something? Myriad Pro. There's nothing pro about Myriad. All right. I don't know why I hate Myriad, but it's the worst. It's even worse than Papyrus. Oh my gosh. That's a low bar, and yet somehow, some way. Comic Sans. Oh, who knows? Let's see. Hennifer, don't quote me on how that's spelled. Surface and let's see here. Oh, here we go. And copying and pasting from Windows to Mac. Control C, Command V. That's such a pain in the ass. All right. Again, Control C. My whole life is just negotiating this shit. You know what I mean? Like, oh, it's just so blah. All right. Wait, no. Yeah, I hit Command. Control C. Command V. All right, we're going to say X equals Y equals Z equals. Clearly that's not going to fit so well. Let's see here. When in doubt, here's what I like to do. Where is it? Oh, it's on the desktop. Sorry, I'll just open it up from the desktop. Larkin building graphs test, Larkin building test. There we go. That's the template. All right, that's the grid. Unlock the guides, just select them, copy, and paste in place. Yeah, that works. Ish. Clearly I could do better than this, so let's see here. I'm going to unselect that and that. What else did I select? I selected all these guides. Oh, come on. Lock that. Take 2. Here we go. Right, so what I do is try to center these up maybe. Okay. Good enough. You tired? Right on. Here's what I'm thinking. This could either be the greatest idea ever or the worst. We're going to find out one way or the other, aren't we? All right, so let's see. Make that axon fit in the 2x2 that's resulting. There's the viewport rectangles. It doesn't look so bad. Now, if I move all this up, then I have a bottom set of cells. For this stuff to actually like have some room to breathe. And then give it a little bit of more visual hierarchy here. 10, bold. You guys want to see the greatest visual hierarchy meme I've ever seen in my life? It's very effective. Fuck yeah, get out of my brain. Come on, all right, right? Unbelievable, right? So these are the tricks we have to play, right? This is why you went to school, to practice this stuff, right? So we'll work this out as we go. This is not what I'm too concerned about, formatting the text, but we'll figure it out, all right? What I'm going to do is I'll upload this and offer this as this sort of starting point, right, for what the result might look like for each of these surfaces. Let's go through the list and let's start to designate some of these. And some of these are a little more complex than others, right? So I'm always open to, somebody who wants a challenge, right, that seems really good at it or likes math or something. If you want to, just knock yourself out. Test, surf. Couldn't even spell surf correctly. That's great. All right. Replace. And all right. So I'll leave that up because I'll post that. I don't need this anymore. Right. Okay. And I'm going to go ahead and stop recording now because I forgot I was doing that.